So, welcome to the next lecture of IDE. In the previous lecture, we were discussing spring mass systems, uh, spring, sorry, spring mass systems, and we have discussed three kinds of spring mass systems. First of all, free undamped motion. The second one was free damped motion. And the third one was forced or driven motion. Driven motion. In the driven motion, the motion could be undamped or damped, both. Either undamped or damped motion. Let me add the people they're trying to now. Yes. If you have any question regarding these three things, free undamped motion, free damped motion, and driven motion, and yeah, in the driven motion, the motion could be undamped or damped, both, or damped. And the model in the third case, which we derived, was m d square x by dt square plus beta dx by dt plus k times x is equal to f of t. This was the model for the driven motion or forced vibrations, forced oscillations we कहते हैं इसको. Okay, we also call it forced oscillations. So this was the model. In fact, this model works for all the three cases. When we have damped motion, this factor is due to the damped motion. Damping force, आप कह सकते हैं. This factor is due to damping force. Okay, and this factor is due to restoring force. Restoring force, and this one is basically the force, or you can say these forces set that mass into motion, and the motion of that mass is basically mass time its acceleration. This is basically this whole thing is Newton's second law of motion. This whole equation obeys this Newton's second law of motion. I hope you remember I have explained all this in my previous lectures. Now, what is this? This force is basically an external force. External force which we apply on the spring mass system in order to generate the force oscillations. This force basically helps the mass to vibrate. This force is basically external force, which helps the mass to oscillate around its basically equilibrium position. Now, this external force, I told you in the previous lecture, that it is usually of this kind. F of t is equal to some constant time sine of some other constant, maybe C1 or C2 times t, or this may be constant times the cosine of some other constant, this. So these are basically a kind of oscillating forces, simple harmonic motions, simple harmonic kind of forces which we apply on the spring mass system externally. So this was this is basically a brief review of the previous two lectures in which we have discussed spring mass system. So free undamped motion, free damped motion, driven motion, force oscillation. This includes undamped and damped motions. How can it include damped or undamped motion? If this factor beta is 0, then this driven motion is undamped. Okay, you can say that forced undamped motion. So in this case, in this equation, beta must be 0. There is no damping force in the spring mass system, and we obtain md square x by dt square plus kx is equal to f of t, where this f is what? It is basically external force which is applied on the spring mass system to help or to generate the vibrations or oscillations. So this is all about the spring mass system. Now let's discuss an application of these kind of models of the spring mass system. I hope you have I hope many of you have or know how to drive a motorbike or a car or any other vehicle. For example, a motorcycle. We consider the motorcycle example, which is given in my notes. Okay. Spring mass system, or you can say motorcycle suspension system, or you can say that. You might have seen the motorcycle suspension system. It's basically a spring attached to just below the handle of the motorcycle, attached to the wheel of that motorcycle in the front, and as well as on the back wheel. There are suspension systems of the motorcycle. So let's consider that this example I have given in my notes on page 36. You can open my notes and have a look at this example. So what is this example? A motorcycle weighs 204 pounds. So the weight of motorcycle, I'm gonna write the given data along with I read this question or example. A motorcycle weighs 204 pounds. So its weight is 204 lb, and we assume a rider weight is 180 pound. Okay. Rider weight means a person who mount the motorcycle. Rider weight is 180 pound. Okay. So you can say that this is the weight of the motorcycle, and this is the person who mount the motorcycle is of 180 pound. When the rider mount the motorcycle, the suspension compresses 4 inches. Okay. So when a rider, any person, sit on that motorcycle, the suspension of that motorcycle compresses. Okay. Definitely due to the weight of that person. So the suspension compresses 4 inches and then comes to rest at equilibrium. Okay. Now, what is the compression is basically it's S, and it is 4 inches. Or 4 inches, or you can say this is 4 by 12 and 1 by 3 feet. Now, furthermore, the suspension system provides damping force. Furthermore, the suspension system provides damping force equal to 240 times the instantaneous velocity of the motorcycle. So we have a damping force F, we call it FC, and it is 240 times the instantaneous velocity, and it is dx by dt. Now, what is the question now? The question is, you have to set up a differential equation, set up an ODE that describes this thing or this situation, this problem, set up an ODE that models the behavior of the motorcycle suspension system. Set up an ODE that models motorcycle suspension system. Motorcycle suspension system. How does that suspension system behave, or how does it moves? In fact, we have to model the motion of the suspension system of the motorcycle. I hope you get it. If you have any question, you can ask me. G. Mursal, if you have any question, you can ask me. Otherwise, kindly mute your mic. So this is the given data. And what is the B part? In the B part, we have to determine, again, the complete model along with the initial conditions. The B part is, if the motorcycle takes a jump, what we have to investigate further, if the motorcycle jumps and land on ground. A motorcycle, maybe you see, you pass on a jump and motorcycle, it basically takes a jump, okay, and land again on the ground. Find the equation of motion of the motorcycle after the jump. Okay, we need to find the equation of motion of the motorcycle after the jump. So when the motorcycle takes the jump, it is in air. Okay, remember that the motorcycle will be in air. So further, it says that assume that t is equal to 0, denote the time when the motorcycle first contacts the ground, and motorcycle hits the ground with a velocity, with a downward velocity of 10 feet per second. Okay, so this is the second part. I hope you can read it in my notes. Let's save some time not to write all these this question. I'm going to repeat it. If the motorcycle takes a jump, okay, so the motorcycle, when it takes the jump, it's in air. Okay, so its wheels are not touching the ground. So we need to find the equation of motion of the motorcycle after the jump. Assume that t is equal to 0, denote the time when the motorcycle first contact the ground and motorcycle hit the ground with the downward velocity of 10 feet per second. So what does it mean? When the motorcycle basically at time t is equal to 0, the motorcycle is just above the ground. Okay, its first contact is t is equal to 0. Now, when the motorcycle is in air, its compression, its suspension system is no more compressed. We know that in the first part, we discussed that the compression is 4 feet when the rider mount the motorcycle. Okay, so there is a compression. The string of that suspension system will be compressed. Okay, so there must be a compression of 4 inches. But when the motorcycle is in air, that spring will be uncompressed. And there at t is equal to 0, the distance of or the position of that bike or the suspension system is what at t is equal to 0, it is 4. Because the suspension is now uncompressed. What's happening? It's not giving the clear picture. Can you see me clearly? Now, yes, it's okay. Now, I hope you get it. Why we write it x of 0 is equal to 4? Because when the motorcycle jumps, it's in air and the suspension system is uncompressed. How much it is uncompressed? It is 4 inches uncompressed. So x of 0 is equal to 4 and the motorcycle hit the ground with the velocity x dash of 0 is equal to 10 feet per second. Okay. So this is basically the model. यहाँ पे it is uncompressed 4 inches because it was compressed 4 inches. So it was uncompressed again at t is equal to 0, 4 inches. So x of 0 is equal to 4 inches, or you can say 1/3 feet, because other these units are feet per second. So we have to convert this unit also in the feet. So these are initial conditions. X of 0 equal to 1/3 feet, x dash of 0 equal to 10 feet per second, along with that equation, which we have assumed here. No, we haven't yet written the differential equation. We know that the weight of the bike is this, rider weight is this, compression is this, and the damping force is this. This is what? It is damping force. Okay. Now, we can write a differential equation which includes, and there is no forced, there is no external force on the system. Okay. So, how can we write a differential equation? It is basically a question of free damped motion. Okay. So, it is a problem of free damped motion. So, in a free damped motion, what is the differential equation which we write? It is md square x by dt square plus beta dx by dt and plus k times x is equal to 0, because there is no external force on that suspension system. Okay. Now we need to calculate m, beta, and k. Beta is actually given. It is 240 because the damping force is what? The damping force is 240 times dx by dt. So the value of beta is 240. Now we know that motorcycle weight is this, rider weight is this. So the total weight must be, total weight is what? 204 plus 180, it is 384 pound. So this is the total weight. Okay. Now using the Hooke's law, what we can say that the total weight is equal to the restoring force in equilibrium position. Total weight is 384 and Fs is what? It is K times S. What is S? It is 1/3 feet. So K is what? K is 384 multiplied by 3, which is 1152. 1152. So this is the value of K, and we can similarly calculate M, the value of mass. So as we know that the total weight is 384, and we need to calculate mass, and it is equal to mg. Okay. So G, the value of G in British SI units is 32. So M is what? It is 384 divided by 32, and it gives us 12 slugs, in fact. So this is your mass. Now we have the value of m, we have the value of k, we have the value of beta. So the equation of motion is what? It is 12d squared x by dt squared plus 240. Yes, the damping force is 240 times instantaneous velocity. So it becomes 240 times dx by dt plus k is what? It is 1152, x is equal to 0. So this is your equation of motion, where x represents the motion of that suspension system of the motorcycle. Okay. So this is the differential equation along with this, this and this initial condition. Okay, we have two initial conditions. We have a differential equation, and what is this? This is a basically second order homogeneous linear ODE with constant coefficients. So we can easily solve it. Not we can, you can solve it because we know how to solve an ODE with constant coefficients, homogeneous ODE with constant coefficients. I hope you can do it. And after solving it, we get the solution. And what is the solution? The solution is, let me write it on the board too. Here. After solving it, we get the solution x of t is equal to c1 e raised power minus 8t plus c2 e raised power minus 12t. And using initial conditions are what? X of 0 is equal to 1 by 3 and x dash of 0 is basically it is 10. So we get, after using these conditions, we can find the values of constants, C1 and C2, and the values of constant is 7 by 2 e raised power minus 8t plus minus 19 by 6 e raised power minus 12t. So this is required solution or the value of x of t, which describes the position of the suspension system of that motorcycle. Now we can calculate the position of that suspension system or the motorcycle at any time t. So these kind of problems basically we solve, or a company which manufacture motorcycle suspension system, they need to solve these kind of problems in order to know how much flexible or how much sustainable those suspension systems of the motorcycle should be, so that when a rider takes a jump, usually in bike races, there are uneven roads. Okay, when a motorcycle takes a jump, okay, on an uneven road, whether on any jump or any other thing, when it flies, or it basically when the motorcycle is in air after the jump, when it lands, how much that suspension system should be strong so that the motorcycle doesn't crash, or maybe the motorcycle, the rider doesn't fall from the motorbike, because the suspension systems, they play a very important role when a motorcycle land after taking a long jump. So these kind of problems we need to solve in order to manufacture the suspension systems of bikes, vehicles, or maybe aeroplanes. You know, suspension system of aeroplanes, they must be very strong because they have to land from a very high altitude on a ground with a very high speed. So the suspension system of the tires, wheels of the aeroplane, they should be very strong. So these kind of problems, spring mass systems or free damp motions, driven motions, these kind of problems we use to model the problems of suspension systems of different vehicles, maybe heavy trucks, airplanes, motorbikes, and many other things. And similar kind of problems you can also see in the civil engineering when the crane, uh, in order to construct a bridge, a crane lift a big block of concrete from one place, and that crane has to put that big block of concrete onto some specific place. Then the wire hanging from the crane and the weight and the mass, which is basically hanged with that wire. That system is also a kind of spring mass system. We can model how much strong that wire should be along with the crane, so that the maximum or the specific number of weight it could sustain in order to lift some weight, some object from one place to other place. So these kind of problems we use in these kind of applications. Now, if you have any question, you can ask me. Otherwise,
सर एक क्वेश्चन था
जी बेटा दनियाल बोले.
जी सर, जब हमने F इज इक्वल टू के ई हुक्स लॉ किया है तो जो कंप्रेशन प्रोड्यूस हुई है वो तो राइडर के माउंट करने के बाद हुई है, तो हमने टोटल वेट क्यों लिया यहाँ बाइक का और राइडर का दोनों?
देखिए, when the rider mount the bike, अब आपके पास दो वेट हो गए ना, एक तो राइडर का वेट है, एक बाइक का वेट है, ठीक है. And when the person sit on that bike, suspension system first moves up and down, and then it stops moving. It is in equilibrium position. You got it, Daniel?
ठीक है सर.
क्योंकि उसके ऊपर राइडर भी है और वेट भी है, दोनों वेट है ना, तो वेट का तो डेफिनेटली सम हमें लेना, ठीक है. अब जब इक्विलिब्रियम पोजीशन में है तो जो सस्पेंशन सिस्टम होगा मोटर बाइक का वो कंप्रेस हो जाएगा, ठीक है. तो कंप्रेशन क्या है उसमें? कंप्रेशन ही तो उसी को तो हम एस कहते हैं ना. एस इज बेसिकली कंप्रेशन और इलोंगेशन, ठीक है. तो आपके पास इलोंगेशन कितनी है या कंप्रेशन कितना है? 4 इंचेस है, which is basically your S, ठीक है. अब जब इक्विलिब्रियम पोजीशन में होगा, इसका मतलब क्या है कि रिस्टोरिंग फोर्स जो है उस सस्पेंशन सिस्टम की या स्प्रिंग की, वो किसके इक्वल होगी? उसके टोटल वेट के इक्वल. इसीलिए तो वो इक्विलिब्रियम में है ना, ये सारा जो सिस्टम है suspension system. When any system is in equilibrium position, what does it mean? Restoring force and weight force, they are equal. Okay?
ठीक है.
तो यहां पे हमने क्या कहा कि टोटल वेट, क्योंकि बाइक और राइडर दोनों बेसिकली राइडर इज ऑन दैट बाइक, तो वेट का सम हो जाएगा ना, ठीक है. सो द सम ऑफ वेट जितना भी है 384, दिस मस्ट बी इक्वल टू द रिस्टोरिंग फोर्स ऑफ दैट सस्पेंशन सिस्टम. Means suspension system he wants to get back to the original position, ठीक है. ये मैंने आपको वो चेंज नहीं किया बोर्ड. हाँ, लेट मी गो बैक टू द बोर्ड 1. मैं आपको यहां से एक्सप्लेन कर रहा हूं ना. देखिए, वेट आपने राइडर और बाइक दोनों का लेना है. टोटल वेट 384 है. जब राइडर बाइक के ऊपर है, उस सस्पेंशन सिस्टम पहले थोड़ा सा मूव करेगा एंड देन स्टॉप मूविंग. इट इज इन इक्विलिब्रियम पोजीशन. When a spring mass system is in equilibrium position, the weight force and the restoring force is what? That spring or that suspension system, he wants to get back to the original position, ठीक है. तो उतनी ही फोर्स उस पर लगाएगा जितना उसका वेट है, ठीक है. तो यहां पे हमने फिर कहा कि वेट इज इक्वल टू द रिस्टोरिंग फोर्स, एंड वेट इज 384, एंड रिस्टोरिंग फोर्स इज k times s, where s is what? It is the extension or compression in that spring, ठीक है. So the compression is S, which is 4 inches, and it is 1/3. So our K is this. We can find the K. I hope you get it. If you have any question further, Daniel, you can ask me.
सर बस एक और चीज क्लेरिफाई करते हैं कि जब राइडर नहीं बैठा तब भी कोई कंप्रेशन होएगी?
नहीं होएगी. फिर मोटरसाइकिल पे जब राइडर नहीं है तो उस सस्पेंशन सिस्टम को इस तरह डिजाइन किया गया है कि उसमें कोई कंप्रेशन नहीं होती, ठीक है. वो टोटली बेसिकली नॉर्मल पोजीशन पे होगा, ठीक है. हम ये मॉडल क्या कर रहे हैं, when the rider is sitting on the bike and bike takes a jump and is in the air, and what happen when the bike will land on the ground. ठीक है, how
ठीक है
much
सर, समझ आ गई।
strong that suspension system of that bike is so that it doesn't break down. ठीक है, it may sustain that jump so that the rider may not have any accident. ठीक है,
ठीक।
so this is what we are going to model. So this is basically, it's a test for the strength of a suspension system, how much that suspension system of the bike is, so that when the rider takes a jump and how much high jump it can take the rider, so that when the rider land on the ground again, the motorcycle suspension system doesn't crash, or any other part of that motorcycle doesn't crash. ठीक है, या ये भी ना हो कि मोटरसाइकिल अगर सस्पेंशन सिस्टम नहीं है तो जब वो लैंड करेगा तो द राइडर कैन फेल ऑफ द मोटर बाइक. ठीक है, ही माइट हैव एनी एक्सीडेंट. ठीक है, तो इन चीजों से इन ऑर्डर टू अवॉइड दीज सिचुएशंस वी हैव टू मॉडल द सस्पेंशन सिस्टम. ठीक है, इसमें एक दो और क्वेश्चंस हैं. देयर आर कपल ऑफ अदर क्वेश्चंस व्हिच यू हैव टू address. I'll send you those questions later on. Okay, similar kind of questions. Now, instead of motorbike, you can have any other vehicle. Okay, you can put here a motor car, okay, a racing car, maybe aeroplane. The question will be basically modified a little bit, but the suspension system of these things will be modeled by using these spring mass systems. I hope you get it. If you have any question, you can ask me. If you don't have any questions regarding the spring mass system, let us start the next topic, which is power series method for solving differential equations. Okay. Let me clean this board. The next thing which we are going to discuss is power series method for solving ODEs. Okay, this one. In particular, second order homogeneous ODEs. Homogeneous ODEs with, previously we discussed how to solve second order ODEs or the higher order ODEs with constant coefficients. Now we are going to discuss how to solve higher order ODEs, particularly second order homogeneous ODEs with variable coefficients. With variable coefficients. Okay. Means we are going to solve this kind of differential equation, a2 of x d square y by dx square plus a1 of x d dy by dx plus a naught of x y is equal to 0. So in this case now, these coefficients a2 of x, a1 of x and a naught of x, they are functions of x, are functions of x, e.g. polynomial functions, trigonometric functions, exponential functions, or any other kind of functions. Why we focus on the second order differential equations? Because um in physical and engineering systems, most of the real life phenomena, they can be modeled uh, as a second order differential equation or system of first order differential equation. Okay, so that is why we focus uh, on the second order differential equations, homogeneous as well as non-homogeneous. Okay. We have studied an undetermined a method of undetermined coefficients to solve the non-homogeneous differential equations with constant coefficients. Now we are going to discuss how to solve homogeneous second order differential equations. You can apply this method on higher order differential equations as well. There's no restriction, or it's not like that this method cannot be applied on a third order system. We can apply this method on third order homogeneous differential equation with variable coefficients, fourth order, but this method basically it becomes very complex when higher order derivatives they involve in the equation, in the ordinary differential equation. But still we can use this method to solve third order, fourth order differential equation. The procedure is same, but we will concentrate on second order differential equation. Now, what is this power series method? In this method, we need to know what is a series. I hope you know what is a series and what is basically the convergence of a series. What is the radius of convergence of a series? Maybe interval of convergence of a series. I hope you have studied all these things in your Calculus 2 course, maybe, or in A levels, intermediate. Have you studied power series, sorry, series, sequences and series already or not? Anyone? Do you know about the sequences and series? Have you ever studied sequences and series in your earlier classes? If there is anyone who haven't already studied these things. For example, what kind of differential equation we are going to solve by using this method? Examples. For example, x square, maybe x square minus 25 y double dash plus x y dash and minus y equal to 0. Maybe another example could be x square y double dash minus 2 y dash plus x y equal to 0. Okay. So these kind of differential equations cannot be solved by any technique which we have already discussed. Method of undetermined coefficient, we cannot use that method to solve these kind of differential equations. There is a question in the chat window, maybe I haven't seen it. Okay. You know a little bit about the series and power series. I'll briefly explain these concepts and then we shall discuss how to use series or the power series to solve these kind of differential equations. Why we need to, we need some method which can handle these kind of differential equations which have basically variable coefficients. Variable could be polynomial, or the coefficients could be, for example, x y double dash plus cos x y dash plus maybe e raised power x y equal to 0. So the coefficients could be any function of x. So here we have a polynomial, here we have a trigonometric function, here we have exponential function. We'll discuss how to solve these kind of differential equations, because these differential equations cannot be solved by any analytical technique which we have already discussed. For example, method of undetermined coefficient. It cannot be used to solve these kind of differential equations because the coefficients are not constant. That method is only employable if the coefficients of these derivatives and y are constants. Now, let's start with the series. A series, what is the definition of the series? Let me briefly write here for you. Informally, an infinite series is the sum of an infinite sequence of numbers. Okay. What is a series? Infinite series, in fact. Infinite series is a sum of sequence of numbers, and we denote it by summation n from 0 to infinity. You can say a n. Okay. What is this? Sum of a n from n 0 to infinity. And how do we expand it? We can write it a0, a0, a1 plus a2 plus so on plus an plus so on. It's an infinite series. This is how we denote an infinite series, and this term is called nth term of the series. Okay. This is basically the definition of the series. Now, one more thing which is very important, that the index, summation index, this is basically the summation index or the sum index. Sum index is always dummy. Summation or sum index is dummy. Dummy means we can change the notation or the symbol of this index. Is n is equal to 0 to infinity, an, it gives us what? Same as k from 0 to infinity, a k. So when you vary the value of k from 0 to infinity, a k, or summation n from 0 to infinity, a n, these both things will give us the same sum of the terms. ठीक है, यहाँ पे फिर general term को आप एक k कह दें, that will be called kth term. So it doesn't change anything. ठीक है. So these are basically some important things to remember for the infinite series. Okay. Now, what is the convergence of a series? Convergence of a series is basically convergence or divergence of a series. Informally speaking, what is the convergence and divergence of a series? Convergence of a series means that the sum of this series is finite. Okay. When we can add up a series, all the terms, infinite terms, when we can add them up and we get a finite sum, a finite value, then the series is called convergent. Convergent means this series has finite sum. Divergence of a series means what? This series in which we are adding up the infinite terms, it doesn't have a finite sum. It is when we add up the terms successively, it will definitely go toward infinity. It doesn't have any finite sum. I hope you get it. The convergence of a series means the series has finite sum. When we add up all the infinite terms, we get a finite sum, a finite value. Then we say that आप informally कह सकते हैं इसको, ठीक है. Divergence क्या होता है कि किसी भी सीरीज देखें, फॉर एग्जांपल अगर हमारे पास ये एक सीरीज है, summation n from maybe 0 to infinity 1 plus n, this, ठीक है. अब इसमें an आपके पास क्या है? This is your an is 1 plus n. अब अगर इस सीरीज को एक्सपेंड करें, n 0 पुट करें तो 1 आएगा, प्लस n 1 पुट करेंगे तो 2 आएगा, n 2 पुट करेंगे तो 3 आएगा, एंड प्लस सो ऑन। अब अगर इसमें 1 + 2 3, 3 + 3 6, 6 + 4 10 एंड सो ऑन एंड अप करते जाएंगे, तो ये सीरीज का सम क्या होगा? up to infinite many terms. Definitely, it will go towards infinity. So this series is divergent because it doesn't have any finite sum. But whereas if we say that अगर आप ये कह दें n from 0 to infinity maybe 1 over n, ठीक है, 1 over n square maybe, ठीक है। अब अगर इसकी टर्म्स को अगर आप ओपन करें, ठीक है, तो ये क्या आ जाएगा? 1 by, इसको 1 से स्टार्ट कर दें। A series can be started either from 0 or 1 or 2. It doesn't change anything because अगर if we have a series, ठीक है, it starts from 1 to infinity or 0 to infinity, ठीक है, depending on the nth term, because here the nth term is 1 over n square. We can put here 0 because it will give us undefined. So a series can be started from either from 0 or from 1 depending on the situation. So it will become 1 over 1, 1 over 2 square is 4 plus so on. Definitely these terms will go towards 0 when n goes to infinity, ठीक है। So ये आपके पास these term up to some certain value of n, the last term would be approximately equal to 0, you can say that. Then we can or add up all those terms and we can get the finite sum. So this series is basically a convergent series, ठीक है। So I hope you know what is the convergence and divergence of the series. This is just an informal, basically, you can speak up informally what is the convergence and divergence of the series. ठीक है, अगर हम थोड़ा सा formally देखें इसको, तो we find the partial sums of the series in order to discuss the convergence formally. What is the partial sums? Partial sums of a series, formally speaking, ठीक है, partial sums. Partial sums of a series. We need to know formally if we want to discuss the convergence. Partial sums क्या है? We write the first term basically S1. Partial sums को हम कहेंगे S1 is A1, S2 is A1 plus A2, and so on. Sn is 1 है तो A1 तक, S2 है तो पहली दो टर्म्स को ऐड किया हमने, Sn होगा तो पहली n टर्म्स को हम ऐड करेंगे, ठीक है, ये An है। So this is basically becoming a sequence of numbers in S1, S2, so on, Sn, and so on. Okay. Whereas when we take up the limit, this is the nth term or nth partial sum, you can say it, nth partial sum. Okay. When you take up the limit, n goes to infinity on both sides. Okay. Here again, n goes to infinity. When n goes to infinity, the partial sums will n will increase. Okay. Obviously, when n goes to infinity, the Sn will contain the whole series. If the limit of partial sums Sn, okay, it is finite, it goes towards a finite number, okay, or this limit exists, then we say that this series converged. Otherwise, we say that the series diverged. This is basically the formal method, but it is not a practical method because we do not use this method to prove whether a given series is converged. We can use it, but normally we do not use it because there are other shortcut methods. There are simple methods in order to check the convergence or the divergence of the series. For example, those methods are, for example, जैसे इसकी एग्जांपल पार्शियल सम्स की मैंने गिवन है यहाँ पे एक नोट्स में look at this example. If you have any problem, you can discuss first with the Furkan, the TA of this course, and if not, you can discuss with me. So आपके पास कुछ टेस्ट हैं, रेशियो टेस्ट है, रूट टेस्ट है, there are some other tests which basically help us to check whether the given series is convergent or divergent. Okay, you can read those tests from the Thomas calculus book, maybe in the sequence and series chapter. Now I'm going to stop about the series here. I hope you can read it yourself, and you can have help from the TA or me. You can fix a meeting with me. I can explain you the concepts because we need to save time here. Now the next, a brief review of power series. This was the series, and the power series is basically a kind of series, a particular kind of series, and we can define it in, for example, y. We can define it y na kya hai, in general kya hai. The power series can be defined as n from 0 to infinity Cn x minus x naught whole power n. This is a very specific kind of a series, but it is still a series. Why we call it power series? Because this series involves a factor of x minus x naught power n. If x naught is 0, then its special case is n from 0 to infinity Cn xn. So why we call it power series? Because it involves the powers of x. That is why we call it a power series. Similarly, here x minus x naught power n, that is why we call it power series. So if we open up this summation, what do we get? We get C0, x minus x naught power 0 is 1, plus C1, x minus x naught, plus C2, x minus x naught whole square, plus so on, plus nth term of the series is Cn, x minus x naught whole power n plus so on. Okay. So again, this can be written as C naught plus C1x plus C2x square plus C3x cubed plus so on plus Cn xn is the nth term plus so on. So these are basically the power series. This power series is basically what? A power series centered at x naught. Okay. This power series is a power series. We call it centered at x naught. And the second one, this one is centered at, is a power series centered at origin. Origin means 0. What does it mean centered at x naught or centered at origin? When we discuss the convergence of a power series, and we need to find the interval of convergence of the power series. Now, interval of convergence is what? Interval of convergence of a power series. Interval of convergence. We need to check for what values of x, because x is a variable here. Because x is a variable here. So if x is a variable, then it must have some domain. Okay, it must have some limitations of the values. So that we call that interval of convergence. It means for what values of in some particular interval, this power series is convergent. Okay? Interval of the convergence is the interval in which whatever the value of x we choose and put here in this power series will converge. Okay? And outside that interval, if we take any value of x, then this series will be divergent. Okay? So that interval is called interval of convergence. Okay? And usually interval of convergence is basically we write it in this way: x minus x naught mod less than r. Okay? Now, if you know inequalities, then what does this mean? It's an interval. What kind of interval is this? If we solve it, we can write it r less than x minus x naught less than r. Okay, and then we can take this x naught on the other side, and it becomes x naught minus r less than x naught plus r. So x can take values between this and this. For all those values of x, the series will converge. Whatever the value of x, between this interval we put in that series will converge. So this is called interval of convergence. And how do we write it? We can write it, sorry, it's open interval. We can write it as x naught minus r, comma, x naught plus r. So this is your interval. And graphically, on a real line, how can we display it? Now, you can see that x naught minus r, x naught plus r. So the center must be x naught. And here we must have negative r length, x naught minus r, and here we have positive r length. This length is what r? This length is. And this point is x naught plus r. So within this interval, this whole interval, whatever the value of x we choose and put in that power series, this power series will converge. And what is the center of this interval? Center of this interval is x naught. That is why we call that this power series is a power series centered at x naught. Okay? And the other one, when x naught is 0, we get 0 here, okay, minus r to r. We'll get this interval. In that case, the power series is basically centered at origin, means 0. Okay? And what is this number? This number is called radius of that interval. Because this is what? This is the radius of that interval. So this number r is called radius of convergence. Okay? What is this called? It is called radius of convergence. Convergence. Okay. This number r is called radius of convergence of that interval of convergence. Okay. Radius of convergence of interval of convergence. Now, in order to check the convergence and to find the interval of convergence, we can use that sequence of partial sums, but that is not a practical method. We can use a ratio test. What is this ratio test? Ratio test basically help us to only find the radius of the convergence of the series, and sometimes it help us to find the radius of convergence and the interval of convergence as well. What is this ratio test? It is limit n approaches to infinity, mod of Cn plus 1 over Cn, mod this. We check this limit. It's a natural that when the n plus 1th term divided by Cn, okay, what does it mean? If this limit exists and it is L, the next term divided by previous term, It's a ratio of n plus 1th term divided by ratio of n plus 1th term and nth term. If this ratio, if the limit of this ratio is finite, what does it mean? That if the now intuitively, if this limit exists and it is equal to L. Now the cases of the convergence. First case is what? If L is less than 1, then what happens? The next term is smaller than the previous term. If L is less than 1. This is what this limit tells us. ठीक है? Intuitively, अगर आप थोड़ा सा सोचें, तो अगर ये लिमिट फाइनाइट है और L लेस देन 1 है, तो इसका मतलब क्या होगा? Cn plus 1 is less than Cn. ठीक है? For all n. इसका मतलब क्या है कि every successive term is less than the previous term. So the series must stop somewhere for some value of n. If that series term stops somewhere, then it will definitely, we can add that series terms and we can get the sum, and the sum will be finite. So if L is less than 1, then the power series जो भी है, then the series converges. ठीक है? सेकेंड केस में क्या है? अगर L greater than 1 है, अगर L greater than 1 है, इसका मतलब क्या होगा कि Cn means next successive term is greater than the previous term. It means the series diverges. क्योंकि अगर हर नेक्स्ट टर्म प्रीवियस टर्म से बड़ी होगी तो डेफिनेटली आपका सम जो है वो इंक्रीज करता जाएगा, तो सीरीज अल्टीमेटली डाइवर्ज कर देगी. तीसरे केस में क्या है? If L is 1, if L is equal to 1, means if this is equal to 1, it means next term is equal to the previous term. If the next term is equal to previous term, it means that every term in that series is equal. And if we add any number infinite times, we'll get definitely infinity. But it depends here on the nature of the series, okay, whether it converges or diverges. In this case, when L is 1, this test is inconclusive. Test is inconclusive. Okay? Means this test doesn't tell us whether the given series is convergent or divergent. Where Cn is the nth term of the series. Okay? आप इसको Cn ना कहें, it will confuse you. आप इसको कोई और कह दें. यहाँ पे maybe An कह दें. ठीक है? This is the nth term of the series. Now when this is basically generally the ratio test. Now in case of power series अगर आपके पास है तो यही टेस्ट क्या हो जाएगा? पावर सीरीज में आपके पास an क्या है? It is Cn x minus x naught whole power n. ठीक है? अब लिमिट किसकी आएगी? n goes to infinity. An plus 1 divided by an is in fact what? It is limit n goes to infinity. Cn x minus x naught, sorry, ऊपर n plus 1 है, यहाँ पे Cn plus 1 हो जाएगा. Cn plus 1 power n plus 1 divided by Cn x minus x naught power n. This mod. अब यहाँ से you can see that यहाँ से x minus x naught power n और ये n cancel हो गया. What do we get here? X minus x naught mod limit n goes to infinity. क्योंकि limit n पे है, यहाँ पे इस पे n नहीं है, we can take it outside. So limit n goes to infinity, Cn plus 1 over Cn. Now, if this limit is finite, ठीक है? It may be some number L, ठीक है. Then or in general, you can say that if this whole limit is चलें आप यही कह दें x minus x naught and this limit is L, ठीक है. Now this whole limit should be less than 1, ठीक है. This whole limit should be less than 1, then we can say that the given power series is convergent. If this whole limit is greater than 1, या आप यहाँ पे कोई और नंबर कह दें, if you are confusing it, तो यहाँ पे m कह दें, ठीक है. If this whole limit is यहाँ पे less than L है, ठीक है. वही तीन केसेस आ जाएंगे. If L is इसको आप equal to L कह दें, ठीक है, equal to L. If this whole limit is equal to L, then if L is less than 1, then the series converges. L is greater than 1, series diverges, and L is equal to 1. This test is inconclusive. अगर यहाँ पे L less than 1 है, तो यहाँ से क्या मतलब होगा? X minus X naught mod is less than 1 over M. ठीक है? ठीक है? If this whole thing M is, you can say यहाँ पे mod है तो definitely positive होगा. So mod of X minus X naught times M. If it is less than 1, then we can say that X minus X naught is less than 1 over M. So here 1 over M, we can call it is R. And what is this? It is the radius of convergence. Whenever we try to find the convergence of the power series and we use the ratio test, it will give us this expression at the end. And from this expression, we can find the radius of convergence as well as the interval of convergence. If this limit goes to maybe 0, the whole thing, then we are unable to find the interval of convergence or the radius of convergence. It means the series is convergent for any value of x. For any value of x means x की कोई भी value ले लें set of real numbers में से, ठीक है? तो उसके लिए convergence obvious होगी. If the series is convergent for all values of x, it means its radius of convergence is infinite and the interval convergence is the whole real line. Okay? I hope you get it. अगर यहाँ पे ये greater than 1 आ जाएगा, तो फिर हम कहेंगे कि this series is divergent. This whole limit is. The same three cases. I hope you get it. If you have any question, you can ask me. Let's have an example of this thing, and then we shall stop it here. For example, this one. Let me, yeah. देखिए, फॉर एग्जाम्पल अगर हमारे पास सीरीज है समेशन n from 1 to infinity minus 1 power n divided by 10 raised power n times x minus 5 whole raised power k, sorry, n. अब हमने ये पावर सीरीज है, इसकी कन्वर्जेंस चेक करनी है, इसका इंटरवल ऑफ कन्वर्जेंस फाइंड करना है, रेडियस ऑफ कन्वर्जेंस फाइंड करना है. तो कैसे करेंगे? आपको पता है कि व्हाट इज दिस होल थिंग? इट इज योर ए एन, ठीक है, या आप इसको सी एन भी कहते हैं, ठीक है. तो हमने क्या चेक करना है? लिमिट एन गोज टू इंफिनिटी ए एन प्लस 1 डिवाइडेड बाय ए एन. सो ए एन प्लस 1 कैसे कैलकुलेट होगा? जहां जहां पे n है वहां पे n प्लस 1 कर दें आप, ठीक है. दिस इज व्हाट वी आर गोइंग टू डू. तो यहाँ पे लिमिट n गोज टू इंफिनिटी, ऊपर वाली टर्म जो न्यूमरेटर में आएगी वो क्या होगी? a n प्लस 1 है, और ये आपके पास a n है. a n प्लस 1 क्या होगा? आप यहाँ पे जहां पे n है वहां पे n प्लस 1 कर दें, डिवाइडेड बाय 10 रेज पावर n प्लस 1 टाइम्स x माइनस 5 रेज पावर n प्लस 1. सो दिस इज योर an plus 1 divided by an वही टर्म आ जाएगी, माइनस रेज पावर n 1 रेज पावर n 10 रेज पावर n टाइम्स x माइनस 5 होल पावर n. ठीक है. अब हम इसको सिंप्लीफाई कर सकते हैं, ठीक है. We can simplify it. We can cancel out the same terms in the numerator and denominator. यहाँ पे देखें ये n जो है ये इससे कैंसिल हो जाएगा. We get only 1. यहाँ पे 10 पावर n से कैंसिल हो गया, सिर्फ 10 पावर 1 रह गया. यहाँ पे -1 raised power n कैंसिल 1 रह गया. So what do we get here? Limit n goes to infinity. ऊपर आपके पास mod है तो -1 की पावर 1 रह जाएगा ऊपर, x -5 की पावर 1 रह जाएगा ऊपर, डिवाइडेड बाय 10 रह जाएगा यहाँ पे. ठीक है. सो वी गेट दिस. नाउ अगर मॉड को अगर हम स्प्लिट अप करें तो लिमिट n गोज टू इंफिनिटी. अब इसमें n है ही नहीं तो लिमिट अप्लाई करेंगे, यू गेट द सेम थिंग. ठीक है. तो आपके पास मॉड ऑफ -1 इज 1, ऊपर x -5 मॉड, नीचे 10 आ गया. सो दिस इज द लिमिट. अब ये लिमिट क्या होनी चाहिए? अगर ये लेस देन 1 है तब ये कन्वर्जेंट होगा, ये सीरीज कन्वर्जेंट होगी. अगर ये लेस देन 1 है तो यहां से वी कैन फाइंड x -5 mod less than 10. So this is your interval of convergence with this thing is radius of convergence. Radius of convergence ये होगा. ठीक है. और इंटरवल ऑफ कन्वर्जेंस आपका, और ये सीरीज जो है, दिस सीरीज इज सेंटर्ड एट 5 because that center of that interval of convergence is 5. This is your x naught. So how can we write it? -10 less than x -5 less than 10, and ultimately we can write it -5 less than x less than 15. So this is the interval of convergence of that series. Within this interval, for every value of x, this series converges. Okay? At endpoints, we are not sure whether the series is convergent or not. Why? Because this is the case when L is equal to 1. This is the third case. Okay? Furthermore, we can check separately the convergence of the series at these endpoints. Okay? Otherwise, this is the interval of convergence, and this is the radius of convergence, and center of interval is 5. How can we draw this thing on the real line? On the real line, it is what? Center is 5. ठीक है. और यहाँ पे आपके पास -5 होगा और यहाँ पे आपके पास 15 होगा. ठीक है. आपका जो रेडियस है यहाँ पे भी 10 है और यहाँ पे भी 10 है, रेडियस ऑफ कन्वर्जेंस. और ये क्या आपका? ये सेंटर है. ठीक है. एंड इट इज x नॉट. आई होप यू गेट इट. What is a power series? What is the interval of convergence of a power series? What is the radius of convergence of power series? And how to check the convergence of a power series? This was a ratio test. You can read some other tests which help us to check the convergence of the power series. In the next class, we shall discuss a theorem which tells us the existence of power series, and then we shall start discussing how to use this method to solve the differential equations. If you have any question, you can ask me. Otherwise, we are going to stop till here today.